So here we are now going to see the extraction of the metals from their ore. Now going to see the metal reactivity series. So as we know, the compounds like iron, zinc, lead and copper fall into this. So what we use to extract this compound, first of all we heat it and then use using agent or displacement reaction with more reactive element to get the metal. So as we know that this compound usually found in sulfides and carbonate, so it is way easier to get this metal from their oxide in respect of their sulfide and carbonate. So first of all what we have to do, we have to convert this sulfides and carbonate in oxide, and then we can get the metal by the reduction. And reduction we use the agent like the copper, coke, or we're gonna see this conversion of sulfides and carbonate to their ore. So first of all we did the zinc sulfate and we react with the oxygen that is converted into zinc oxide plus sulfate. So here the oxygen 2, here 3. So basically multiply by 2, 2, 3, 6, here 2. So here basically we can say the balance the reaction as 2 zinc is there and 4, 6 oxygen is there, 6 oxygen is there. So we must make it forward. Two zinc sulfide plus 3 O2 gives 2 zinc oxide solid liquid sulfate plus 2 sulfur dioxide, that is the gaseous. Now for we have done this conversion where we have given the excess heat. So this process is known as roasting. Excess air, sorry, we are given the excess air. So this process is known as roasting, where we burn the compound with the excess air to convert into the oxide. So this is known as roasting. And when we do for carbonate, we do in a limited air. It is known as calcination. Here we are seeing basically the conversion in oxides. Like if this is the zinc carbonate, and here we give the heat, then it converted into zinc sulfide plus carbon dioxide is released. So if we balance the reaction, then obviously here we get a 2. So here 2, carbon is there, 2 and 2. So zinc is 2, carbon is 2, and 4 and 6 oxygen is there. So we balance the reaction, and this process is known as calcination. So what we have seen, basically we have seen the zinc sulfide conversion into oxide, and obviously the zinc carbonate into conversion into oxide. So this process is done in the limited air called calcination, and when that is done in excess, it is known as roasting. And what we have seen, basically we have seen the conversion of the metal into their oxides. We have seen that we have made the oxide. So basically how to oxide we have to get the metal. So basically how we can do so, basically we have two steps. First of all, the displacement reaction is there, where the higher reactive material replaces less reactive, and the second one is reduction with coke, that is the carbon. So it is a very small procedure. Here we can see here like the zinc oxide plus the carbon here gives zinc solid plus carbon monoxide gaseous. So balance the reaction, carbon is 1, carbon 1, oxygen is 1, oxygen is zinc sulfate is there, and this is also solid. So here the gaseous carbon monoxide is released and zinc solid is formed. So this process where we use a reducing agent as the carbon to reduce the zinc oxide to the zinc metal. So this is how we got the oxide converted into metal. Now we're gonna see the displacement reaction on the next page. The displacement reaction. So we here have seen, like for example, we take the magnesium oxide. Now if we take the higher reactive material like the sodium, calcium and the aluminium. So for the displacement reaction we use the solid aluminium here, the magnesium oxide. So let's form magnesium liquid plus Al2O3 as a solid, and heat. So we multiply by 2 and here the oxygen is 3 so 3, so here it will be also, so we get multiplied by 4. So now if you see the reaction, there is magnesium 3, there is magnesium 6, there are 4 aluminum and 6 oxygen, and also the heat is released because these reactions are exothermic. So let's make it fair. So let's just see now, like the three magnesium oxide, so that is the solid, plus 4 aluminium solid, that gives 3 magnesium liquid plus 2 aluminium oxide solid, plus heat is released. Why heat is? Because it is exothermic reaction, and here we have used the aluminum that is in the powder form, aluminum powder we have used, that is why it is solid. Now for the same we will take the iron Fe2O3. So here this is a solid, we use aluminium. So aluminum do the displacement reaction and we got the iron liquid plus Al2O3 plus heat. So we balance the reaction, there is 2, once again here we Al2O3 and here 2 aluminium, O3 and 2 iron. So the reaction balance will make it fair. Fe2O3 aluminum 2 solid here used, again the powder, and we got here the 2 iron, that is the liquid, plus Al2O3 plus heat. And obviously this is a reaction, the heat is so much that this compounds usually that is formed are in molten stage. So the compound usually formed are in molten stage. At the same time, for this specific reaction, if we talk about the iron reaction, the heat generation can be used to prepare the cracks in railway lines. So we have seen basically the exothermic reaction where we use the highly reactive compound like sodium, calcium and aluminium, and when we react this compounds we get the metal in the liquid form, plus the oxide will be released and heat is released. So basically this is the exothermic reaction, and this is so heat is so much that the these compounded metal we got usually are mental stage. And obviously for the reaction, for the specific for this iron reaction, the heat is released so much that basically these are used to prepare the crack in railway lines, or we can use some heavy machine to use to prepare the cracks in railway lines, or we too can join the railway line using this reaction. So thanks for watching.